Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on 3D Pythagoras, or using Pythagoras' theorem in 3 dimensions. If you need any extra help in this topic, if we go to Corbettmaths and go to the videos and worksheets section, and scroll down to video number 259, there's a dedicated video tutorial there on 3D Pythagoras. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one, we've got this cube. So we've got this cube, A, B, C, D, E, F, G, H. So we've got this cube, and we're told the side length of the cube is 4 centimeters. And we've been asked to work out the length of AG, the length of that diagonal going from here, the front left-hand corner of the shape, to the top right-hand back corner of the shape G. So that line there. I'm actually just going to draw it on the diagram. So I'm just going to get a ruler and pencil, and I'm going to just draw that line AG on the diagram. So it goes from the front left of the shape here to the top right-hand corner here, the back right-hand corner of the shape there. And that's called the diagonal. So that's the diagonal of that cube. And we want to find the length of that diagonal. Now to do that, what we really need to do is, well, we've got one of the sides. We know that CG, so this side here, CG, is 4 centimeters because it's a cube of side length 4 centimeters. That means this would be 4 centimeters, that'll be 4 centimeters, that'll be 4 centimeters. All of those edges have a length of 4 centimeters. So CG has got a length of 4 centimeters. If we join up from A to C, then that'll be another side there of that triangle, and then AG would be the hypotenuse. Actually, I'm just going to mark on AC as well, so that's AC, and then we've got CG. So we've got that right angle triangle there, ACG, and that's a right angle triangle. And we could use Pythagoras' theorem to find the length of AG. But to do that, we need to find the length of AC to begin with. Now, if we have a look here, the base of this cube, we have got this right angle triangle here. ABC, at the base of the cube, is a right angle triangle as well. And we know that AB is 4 centimeters. And the BC is 4 centimeters as well. And we can use Pythagoras' theorem to find the length of AC. So let's do that. So we've got this right angle triangle. The two shorter sides would be AB and BC. So I'm going to label those A and B. And the longer side of that right angle triangle, ABC, would be AC. That's the hypotenuse, so I'm going to label that C. So we've got the A squared plus B squared equals C squared. The two shorter sides squared added together will be equal to the longer side squared, the hypotenuse squared. So let's substitute in those values. So A squared, well, it's going to be 4 squared, so 4 squared, plus B squared, well, B squared, that's going to be another 4 squared, so 4 squared, is equal to C squared, which is AC, I suppose, so AC squared or C squared. 4 squared is equal to 16, plus 4 squared is another 16, equals C squared. 16 plus 16 is equal to 32, so that's 32 is equal to C squared. And then to find the length of AC, which is what we call little c, we would just square root 32. So that means that C is equal to the square root of 32. And that's it. So that means that AC is equal to root 32. Now we could work that out as a decimal number, but it's actually quite handy in these questions to sometimes leave them as surds. So this is a surd, it's got the square root sign there. Actually, if you type in the square root of 32 in your calculator, if you do the square root of 32, you get that's equal to 4 root 2. But I tend to just leave it as root 32 because we're going to actually need this again in a minute. It's actually handy to keep it like that. So that means that the length of AC is equal to root 32. Okay, now if we have a look at this other right angle triangle, ACG, and you can actually sketch it if you want to. You can actually sketch ACG, so you can actually do a little sketch here with a ruler and pencil. So I've just done a sketch of that triangle ACG there. We've got A here, and we've got C there, and we've got G directly above C, and that's the right angle triangle. We know the length of CG, that's equal to 4 centimeters. We've just worked out the length of AC, the length of that diagonal of the base of the cube. That's equal to root 32. You could, as I said, write it as 4 root 2, or even as a decimal number as 5.6568 and so on. But I tend to just keep it like that, and you'll see why in a second. And I'm just going to let AG be equal to X. So the hypotenuse of that triangle is equal to X. Okay, so now let's use Pythagoras' theorem again, because we've got the length of the two shorter sides. We can use Pythagoras' theorem to find the length of the longer side, the hypotenuse. So A squared plus B squared equals C squared. So A squared, well, it's going to be A squared. Let's label the two shorter sides, A and B, and the longer side C. So A squared will be 4 squared plus, and then we've got B squared. So that's going to be the square root of 32 and then squared. I'm just putting that in a bracket for the moment, and that's equal to C squared. That's going to be X squared. Okay, 4 squared. Well, 4 squared is 4 times 4. That's equal to 16 plus, and then we've got root 32 squared. So here you'll notice we've got inverse operations. We're square roots in something and then we're squaring it. So that'll just give us 32. Alternatively, you could consider root 32 times root 32 would be equal to 32. That would make sense because if you squared a number, it's saying what number do you times by itself to get the number. So if you had the square root of 32 and you times it by the square root of 32, the answer would just be 32. And so that's why I just left that as a surd like that, an unsimplified surd, so that whenever I squared it, it would just give us the 32. And that's equal to x squared. Okay, that's fantastic. Now we just need to add those two together. 16 plus 32 is equal to 48, and that's equal to x squared. So that means x squared, that side squared, so x squared is equal to 48. So that means if we want to find x, which is the length of AG, we just need to work out the square root of 48. Now at this point, because we're finished, I'm just going to do the square root of 48. I could write it as 4 root 3 if I wanted to, but I'm going to write it as a decimal number. So that's equal to 6.9282 and so on centimeters. And I'm just going to round that to 4 decimal places because that's going to be 6.9282 centimeters to 4 decimal places. And that's it. So that's the length of AG. Okay, let's have a look at our next question, question number 2. So question number 2, this time we've got a cuboid and we've got the lengths of some of the edges. We've got that AB is equal to 8 centimeters. So that means that DC would be 8 centimeters, EF would be 8 centimeters, and HG would be 8 centimeters as well. And then we've got the length of BC. BC is equal to 3 centimeters. So that means that FG would be 3 centimeters, EH would be 3 centimeters, and AD would be 3 centimeters. And then we've got the height of the cuboid. The height of the cuboid is 4 centimeters. That means that CG is equal to 4 centimeters. So it would be BF, AE, and DH. And that's it. So we want to find the length of AG. So again, that diagonal going from the front left-hand corner of the cuboid to the back right-hand corner of the cuboid. So that front bottom left corner to the upper right back corner there. And I'm just going to draw it on again. So I'm just going to get ruler and pencil and draw on AG. So again, we want to consider the triangle ACG. We want to get that triangle there, because if we know the lengths of 2 of the sides, we can use Pythagoras' theorem to find the length of AG. Now we already know what the length of one of the sides. We know that CG is equal to 4 centimeters. So it'd be fantastic if we could work out the length of AC. So to find the length of AC, we're going to look at this base. So if we look at the base of the cuboid, we have got a right angle triangle here, ABC. So ABC is a right angle triangle. If you join up the opposite corners of that rectangle, you'll have a right angle triangle there. So AC would be the hypotenuse of that right angle triangle. So A and B are the 2 shorter sides. I'm just going to label them A and B, and C would be the longer side. So let's use Pythagoras' theorem to work out the length of AC. So A squared plus B squared equals C squared. So A squared, that's going to be 3 squared, so 3 squared, plus B squared, that's going to be 8 squared, is equal to C squared, so that's going to be C squared. 3 squared, that's equal to 9, plus 8 squared, that's equal to 64, and that's equal to C squared. So 9 plus 64 is equal to 73, and that's equal to C squared. And then if you square root, we're going to find that C is equal to the square root of 73. So that means the distance from A to C would be root 73 centimeters. And actually, if you wrote it as a decimal number, the square root of 73 is equal to 8.544 and so on centimeters. Now I tend to leave it as a surd because if I was to use 8.544003745, I'd have to keep writing that down because I don't want to round it, because if you round it, you're going to lose some accuracy whenever you're dealing with these questions, because obviously we're going to be using that value again. So if you write it down as root 73, later on you'll find that we're squaring it, so then we'll end up with 73 again. So that's why I leave that as a surd. Okay. So now we have found the length of AC, the length of that diagonal of the base there, the length of that diagonal, AC. Now if we have a look at the triangle ACG, that's another right angle triangle. That's a right angle triangle there. So we've got the length of AC, that's equal to root 73. That's one of the shorter sides. We've got the length of CG, that's equal to 4 centimeters. And then we want to find the length of AG, so that's going to be the hypotenuse. So let's sketch that triangle out. So we've got ACG, and that's a right angle triangle there. AC, that's equal to root 73 centimeters. CG, that's equal to 4 centimeters. And then AG is what we want to work out. I'm just going to call that X for the minute. Okay, so we have got the lengths of 2 of the sides, the 2 shorter sides, and we want to find the length of the hypotenuse. So let's use Pythagoras' theorem again. So let's label the sides, A being the shortest and B being the middle. Now it doesn't actually matter which way around those 2 are labelled, as long as the longest one, AG, is labelled as C. So we've got A squared plus B squared equals C squared. A squared, well, that's going to be 4 squared, so 4 squared, plus B squared, that's going to be root 73 squared. And again, I'm just leaving that as a third because I know that when I square it, I'm just going to be left with 73. And that's equal to c squared, but c was x, so we're just going to call that x squared. 4 squared is 16 plus, and then we've got root 73 times root 73, that's just going to be 73, and that's equal to x squared. Now if we do 16 plus 73, that's equal to 89, and that's equal to x squared. So it means that x squared, this side squared, is 89, but if we square root that, we're going to get that x is equal to root 89. Okay, so now we're finished. I'm just going to work that out as a decimal number. So the square root of 89 is equal to 9.433981132 centimetres. And I'm just going to round that. I'm going to round it to 3 decimal places. So the 3 decimal places, that'll be 9.434 centimetres to 3 decimal places, to 3 decimal places. And that's it. So we've worked out the length of that diagonal of that cuboid, which is 9.434 centimetres to 3 decimal places, or root 89 centimetres. And that's it. Okay, let's look at our next question, question number 3. So question number 3 says the tree is located in the corner of a rectangular field. So it's located in the corner of this rectangular field. So we've got this rectangular field. Now it may look a bit like a parallelogram, but we're looking at this from a 3D perspective. So here we've got this rectangular field. So it's a 10 meter by 9 meter field. It's a rectangular field. And this tree's in the back right hand corner of the field. And we're told that the tree is 4 meters tall. And if we go on down, we're told to calculate the length of AE. So that would be the distance from this front left-hand corner of the field, this front corner here, all the way to the top of the tree. So I'm just going to draw that on the diagram now. So I'm just going to get a ruler and pencil and join up from A to E. So we're going from the front left-hand corner of the field all the way to E, which is above the back right-hand corner of the field, so vertically above. Actually, I'm just going to draw that on as well, from C to E. Okay, actually, I'm just going to move it to there. Okay, so that top of the tree should be directly above that back right-hand corner there. Okay, so we want to find that distance AE. So it's just like the last two questions, really. So what we're going to need to do is we're going to need to find the length of AC. And you can see now we've got that right angle triangle ACE. So that's a right angle triangle. I'm just going to mark it on there with a right angle sign there. So we've got that right angle triangle. So before we work out the distance AE, what would be really useful is if we can work out what AC is, because we know that CE is 4 meters. If we can look at this rectangle, now remember it's a rectangle we're looking at from a 3D perspective. So here we've got this rectangle and we've cut it across diagonally, so that will be a right angle triangle as well there. So that's a right angle there, and we've got that's 9 meters, and that means that this length here will be 10 meters, and we can use Pythagoras' theorem to work out the length of AC. So let's do that. So that's going to be the hypotenuse of this right angle triangle. So A squared plus B squared equals C squared. Let's label the sides. A and B are the two shorter sides, and C is the hypotenuse. So we're going to do A squared, which is 9 squared, plus B squared, which is 10 squared, is equal to C squared. And C is what we're trying to find out there, so let's just call it C squared. Okay, 9 squared is 81, plus 10 squared is 100, and that's equal to C squared. So that means that if we add them two together, we're going to get 181 is equal to C squared. And then if we square root, we get that C is equal to the square root of 181. Now, again, I tend to leave it as a third because later on we're going to be using Pythagoras' theorem again, and we're going to square this. So it'd be quite useful actually to leave it like that rather than write it as a decimal number that you may round and then lose a bit of accuracy. So that means that AC is equal to the square root of 181. If you have worked it out as a decimal number, the square root of 181 is equal to 13.4536 and so on. Okay, so that's fantastic. We can now work out the length of AE, what we're trying to find, that distance from this corner of the field to the top point of the tree. So let's actually sketch that triangle ACE. So I'm just going to get a ruler and pencil, and I'm going to draw the line AC to begin with, and then CE, and then that diagonal AE. Okay, and let's label on those measurements. So that means that CE, so that's ACE. CE is 4 meters, that's 4 meters, so 4 meters. AC is equal to the square root of 181 meters, and AE is what we're trying to find out. I'm just going to call that X, and that's a right angle triangle. So as you see, it's a right angle triangle there. So we're going to use Pythagoras' theorem again, and X is the hypotenuse. So let's label the sides, A being the shortest, B being the middlest, and C being the largest. And A squared plus B squared equals C squared. A squared, that's going to be 4 squared, so 4 squared, plus B squared, so B's the length of AC, so it's going to be root 181 squared. And remember, when we square that, that's just going to be 181. And this is equal to C squared, so we labeled that as X. So it's going to be X squared. Okay, so 4 squared is 16, plus the square root of 181 squared would be 181, and that's equal to AE squared, or in this case we've just called it x, so x squared. And then if we add them two together, we're going to get that's equal to 197, and that's equal to x squared. And then if we square root, we get that x is equal to the square root of 197. So let's work that out. The square root of 197 is equal to the square root of 197 is equal to 14.0356 and so on meters. And I'm going to round that. I'm going to round it to 3 decimal places. So the 3 decimal places, that'll be 14.036 meters to 3 decimal places, to 3 dp. And that's it. So that's the length of AE. Okay, let's look at our next question, question number 4. Okay, so question number 4, we've got this open box. So this is an open box, and we've got the lengths of some of the edges. And then we're told that Tim wants to put a 46 centimeter metal rod inside this box. So he wants to put a 46 centimeter rod inside that box. And we've been asked, will the metal rod fit inside the box? And to explain your answer. Okay, so you might look at this and think, well, the height of the box is 40 centimeters. If you put a 46 centimeter rod in vertically in this box, it's going to be too small. But remember that he may put it in diagonally. So the longest measurement in this box will be from this corner to this corner, or suppose from this corner to this corner, or from that corner to that corner, or that corner to that corner, but one of those diagonals. So let's mark on one of those diagonals. I'm going to go from this one to that one there. So that will be the longest distance inside that box, that diagonal. So let's work out the length of the diagonal, and then let's have a look and see, is that diagonal longer or shorter than 46 centimeters, and then figure out, will that metal rod then fit into the box or not. Okay, so let's find the diagonal of this cuboid, and we've already done that in questions 1 and 2. We've had some cubes and cuboids, and we've found the lengths of those diagonals, so just use that same technique again. But in this case, we'll then refer to this metal rod and see, will it fit in or not. Okay, so we want to find the length of that diagonal. So the height of the cuboid is 40 centimeters. That means that the length of that edge is 40 centimeters there. And then if we join up this corner here to that corner, now you can see we've got a right angle triangle. So that's a right angle triangle there. We want to find the length of the diagonal, the length of the hypotenuse, and we've got the length of one of the shorter sides. So let's find the length of this other shorter side here. So if we look at this triangle, which is half of the base here, this right angle triangle here, we can use Pythagoras' theorem with the 15 centimeters and the 20 centimeters to find the length of that diagonal. So let's do that. So in terms of this right angle triangle here at the base, that's going to be one of the shorter sides, A. That's going to be another shorter side, B. And the length of this diagonal here, let's call it C. So A squared plus B squared equals C squared. So A squared, that's going to be 15 squared, plus B squared, that's going to be 20 squared. And that's equal to C squared, so C squared. 15 squared is 225, plus 20 squared, that's equal to 400. And that's equal to C squared. 225 plus 400 is 625, and that's equal to C squared. And then if you square root, you get that C is equal to 25. So that means the length of this diagonal is 25 centimeters. So that's fantastic. So now if we have a look at this other triangle here, we've got the length of the two shorter sides, which are 25 centimeters and 40 centimeters. And then we can use Pythagoras' theorem to find the length of that diagonal. And then we'll figure out, will the rod fit into the box or not. So let's do that. I'm actually just going to do a little sketch here, and then let's mark on those measurements. So 25 centimeters, 40 centimeters, and we want to find the length of that diagonal. I'm just going to call it Y. And it's a right angle triangle. Okay, so Pythagoras' theorem, let's label the sides A, B, and C. So A squared plus B squared equals C squared. A squared, that's going to be 25 squared, plus B squared, that's going to be 40 squared, and that's equal to Y squared. So 25 squared, that's equal to 625, plus 40 squared, that's 1,600, is equal to Y squared. And then if we add these two together, 625 plus 1,600 is equal to 2,225, that's equal to Y squared. And then finally, if we square root that, we're going to find the length of that diagonal. So the square root of 2,225 is equal to, the square root of 2,225 is equal to 47.169 and so on centimeters. So that's fantastic. So now we know the length of that diagonal. The length of that diagonal is 47.1699 and so on centimeters. And that's longer than the length of the metal rod. So let's write down that yes. And that's it. I've just written down that yes, a 46 centimeter rod would fit in the box, as 46 centimeters, the length of the rod, is less than the length of the diagonal, which is 47.1699 and so on centimeters. And that's it. Okay, let's look at our next question, question number 5. Okay, question number 5. So question number 5, we've got this cuboid, and we've been asked to calculate the length of diagonal BH. So we want to find the length of that diagonal BH, and we need to give our answer as a surd. So this question is just like the ones we've done so far. We want to find the length of the diagonal of a cuboid. However, this time it's a non-calculator question. So we're going to have to do this without using a calculator, but we can give our answer as a surd, so we're just going to leave it as a root. Okay, so let's do that. So to find the length of the diagonal, BH, so let's mark on where BH is. So B is here and H is there, so the length of that diagonal. To find the length of that diagonal, I'm going to also want to find the length of BD, because then we've got this right angle triangle, DBH. So DBH is a right angle triangle, and I'm just going to mark on that right angle there. So there's the right angle there. And if we find the length of BD, we know the length of DH already. The height of the cuboid is 2 centimeters. CG is equal to 2 centimeters. So that's 2 centimeters there. So if we can work out the length of BD or DB, then we can then use Pythagoras' theorem to find the length of BH, the length of that diagonal. So let's do that. So let's have a look at the base of this cuboid. We have got here the triangle ABD, and ABD is a right angle triangle as well. And we know that AB is 5 centimeters, the BC is equal to 3 centimeters, and we can use Pythagoras' theorem to find the length of BD, because we've got the two shorter sides and we want to find the length of that hypotenuse. So let's do that. So A squared plus B squared equals C squared. A and B are the two shorter sides, so we're going to have 3 squared plus 5 squared. So 3 squared plus 5 squared equals the length of the hypotenuse squared. So that's going to be, in this case, BD. So BD squared. That's the length of the diagonal. So BD squared. Okay, so 3 squared is equal to 9 plus 5 squared is 25. And that's equal to BD squared. So BD squared, the length of that diagonal squared. Okay, 9 plus 25 is 34. And that's equal to BD squared. And then we want to find the length of BD, so let's just square root that now. So BD is going to be BD is equal to the square root of 34. So that means that BD is root 34 centimeters. So it's a non-calculator question, so I've just left it as root 34. Now, if we have a look at our triangle BDH, this right angle triangle here, we can now use Pythagoras' theorem with the 2 centimeters and the root 34 centimeters to find the length of its diagonal. So let's do a little sketch. So let's get a ruler and pencil and do a little sketch of triangle BDH. So we have got here, there's D and there's H, and then we've got DB across there, and then we have got BH there. So let's label those. So we have got D, we have got B, and we've got H, and that's a right angle triangle. DB is equal to root 34. BH is equal to, that's what we're trying to find, I'm just going to call that X for the minute, and BH is equal to 2 centimeters. So let's use Pythagoras' theorem here to find the length of BH, this value of X. So let's label the sides A, B, and C, the two shorter sides. So we've got A squared plus B squared equals C squared. A squared, that's going to be 2 squared, plus B squared, which is root 34, so root 34, and then squared, and that's equal to C squared, and I've called that X in this case, so X squared. 2 squared is 4, so that's 4, plus root 34 squared will be 34, because the square root of 34 times the square root of 34 would just be 34, and that's equal to X squared, so X squared. And then finally, we just need to add these two together. 4 plus 34 is 38, and that's equal to X squared. And then we need to square root, so X is equal to the square root of 38, and that's it. And that can't be simplified, so the answer is root 38 centimeters. And that's it, that's the length of that diagonal. And we've left it as a surd, like we've been asked to in the question. And that's it. Okay, let's look at our next question, question number 6. So question number 6, we've been given this cube and we're told the surface area of this cube is 433.5 centimeters squared. And we've been asked to find the length of the diagonal of the cube. So we want to find the length of the diagonal, so that'll be from here to here, or from here down to here, or from here up to here, and so on. So we want to find the length of one of those diagonals. So they all have the same length, obviously. Now this question is a bit different than the ones we've looked at so far, because in the questions we've looked at so far, we were told some of the lengths. So we were given perhaps the width of the cube, or the cuboid, or the height of the cube, or the cuboid, and so on. But in this case, we've been told the surface area of the cube. So let's use the surface area to work out the side length of this cube. So if we wanted to find the surface area of a cube, we would find the area of one of the faces, and then we would times it by 6, because there's 6 faces altogether. So if we take the 433.5 and we divide that by 6, that will tell us the area of one of the faces of this cube. So 433.5 divided by 6 is equal to 72.25. So that means the area of one of the faces of this cube is 72.25 centimeters squared. Now that's the area of one of the faces. So let's just focus on the front of this cube here. The area of the front of this cube is 72.25. That would be the length times the width. So if we do the length times the width, that would be equal to 72.25. So if we do the square root of 72.25, that would tell us the side length here. So the square root of 72.25 is equal to 8.5, so 8.5. So that means the side length of this cube is 8.5 centimeters. So let's write that down. So that means that this would be 8.5. It would mean that the height is 8.5. It would mean the depth is 8.5 and so on. Okay, so now we know the side length of this cube. Now let's find the length of the diagonal. So we want to find the length of the diagonal. I'm just going to draw that on the diagram. So we want to find the length of one of the diagonals. So perhaps from the front left here to the top right back there, that diagonal. Now if we want to find the length of that diagonal, what I would want to do is I'd want to consider that right angle triangle there. And as you can see here, that would be a right angle triangle. And we know that this measurement here, the height of the cube is 8.5. So we know that's 8.5. And it would be quite useful if we knew the length of this diagonal, the diagonal of the base of the cube. Because if we worked out the length of the diagonal of the base, we would have the length of two sides, and then we could find the length of the diagonal of the cube. So let's do that. So let's find this measurement here. I'm just going to call it x. So here we've got the two shorter sides. This is a right angle triangle as well. And if we do a squared plus b squared equals c squared, we can find out what x is. So let's do that. So a squared plus b squared equals c squared. The two shorter sides are both 8.5, so that'll be 8.5 squared plus 8.5 squared equals x squared. So now let's work out what 8.5 squared plus 8.5 squared is. And when we work that out, we get that's equal to 144.5. And that's equal to x squared. Now we want to find out what x is, so let's square root. So we'll do the square root of that, and that means that x is equal to, read as a decimal number, as 12.02081528 if you wanted to, or you could write it as a third, so that would be 17 root 2 over 2. So you could write it as either one, so x equals 17 root 2 over 2, or 12.02081528. But if you are using this version here, the decimal number, make sure you don't round it, because we're going to need to use that again. Okay, so now that's fantastic. We found the length of this diagonal here. That's equal to 17 over 2 root 2, or 17 root 2 over 2, or 12.0208 and so on. That's the length of that diagonal. Now we can use Pythagoras' theorem again to find the diagonal of the cube. So let's draw a little sketch of that. Okay, so I've done a little sketch of this triangle here. So the height of it is 8.5. The length of the base of the triangle will be the length of that base, which is the diagonal we just found. You could call it 17 root 2 over 2, or 12.02081528. Make sure you don't round it. It's a right angle triangle. And this diagonal is the diagonal of the cube of what we're trying to find. So let's just call that y. So now let's use Pythagoras' theorem again. We've got the lengths of the two shorter sides, and we want to find the length of the hypotenuse. So a squared plus b squared equals c squared. So a squared, that's going to be 8.5 squared, plus b squared, that's going to be 12.02081528 squared, or as in this case 17 root 2 over 2 and then squared, and that's equal to c squared, the longest side, which is y squared. Okay, now I've already got this in my calculator display, so I'm just going to actually press squared now. So if I just do squared answer, that gives me 289 over 2, or 144.5, this value here. So we've got here, well, I'm just going to write this bit in first. 144.5 is what we get when we square that. Now 8.5 squared is equal to 72.25, and that's equal to y squared. Okay, now let's add these two together and see what we get. So 72.25 plus 144.5 is equal to 216.75, and that's equal to y squared. And then we just need to square root, so let's square root that. And that's equal to, y would be equal to the square root of this, which is 17 root 3 over 2, or 14.72243186. And I'm just going to round that to two decimal places. That'll be 14.72. So that's the length of the diagonal of that cube. And this question was just a bit different than the ones we've looked at so far, because we were told the surface area of the cube rather than the side length of the cube. And we had to work out what the side length was. And then it was just like all the other questions we've done so far, where we find the length of the diagonal of the base, and then we considered that triangle and we found the length of the diagonal. That's it. Okay, let's look at our next question, question number 7. Okay, so question number 7. So question number 7 says, shown below is a triangular prism. So it's not always cubes and cuboids that you use in 3D Pythagoras in. It may be, in this case, a triangular prism. And we're told that triangle ABC is a right angle triangle. So you can see that's a right angle there. That's ABC. And first of all, we've been asked to find the length of BC. So we want to find the length of BC here. Well, that's the front face of this triangular prism. It's just a triangle here. And we want to find the length of BC. So we just want to use Pythagoras' theorem to work out what BC would be. So I'm just going to call that y for the minute. And the 3 centimeters and the 4 centimeters are the two shorter sides, and the longest side would be y because it's opposite the right angle. So let's use Pythagoras' theorem. A squared plus b squared equals c squared. So that's 3 squared plus 4 squared. So you may notice this is a 3, 4, 5 triangle equals y squared. 3 squared is 9 plus 4 squared is 16, and that's equal to y squared. So you get that 25 is equal to y squared, and then when you square it, you get that y is equal to 5. So y is equal to 5, so that means that BC is equal to 5. So let's write that down, that BC is equal to 5 centimeters. Okay, next, we've now been asked to find the length of CD, so CD. So here we've got C, and here we've got D. And if we consider this triangular prism, and we've got this face on the left-hand side of this triangular prism, which would be a rectangle, because remember it's a right angle triangle, so that would be a vertical side there, a vertical rectangle on this side here. We want to find the length of CD. So I'm just going to join that up. So I'm just going to join up from C to D. And that's a diagonal of a rectangle because ACFD, that's a rectangle, and then that would be a right angle triangle there. We know that AC is equal to 3 centimeters, and we also know that AD is equal to 8 centimeters because the depth of this triangular prism is 8 centimeters, so that'd be 8 centimeters as well. So this is a right angle triangle with a base of 8 centimeters and a height of 3 centimeters. So let's sketch it. Okay, so there's our right angle triangle. That would be A. That would be C, and then that would be D. The height is equal to 3 centimeters. The base would be 8 centimeters, and we're trying to find this diagonal CD. So let's use Pythagoras' theorem. So these are the two shorter sides. So we've got A squared plus B squared equals C squared. Okay, so A squared, so that's going to be 3 squared, plus B squared, that's going to be 8 squared. And that's equal to C squared, so it's going to be CD squared. So it's the length of CD squared. 3 squared, that's 9, plus 8 squared, that's 64, is equal to CD squared. And then 9 plus 64 is equal to 73, and that's equal to CD squared. So CD would be the square root of 73, and that's it. So you could leave it as a third if you wanted to, as root 73, so the square root of 73. Or you may write it as a decimal number, and that would be 8.544 to 3 decimal places. So let's write that down. 8.544 to 3 decimal places, and that's it. And I'm just going to move this working out down here. Okay, so that's part B done. Now let's have a look at part C. So part C, we've been asked to work out the length of CE. So let's go back up to our triangular prism and let's consider CE. So I'm actually just going to get rid of that diagonal line for the moment, just so I can see a bit more clearly here. So we've got this triangular prism, C's here, and then E's here. So if we consider that rectangle there, so this right-hand face of the triangular prism, so that would be that sloped rectangle there. If we join up C and E, so let's join up C and E. So C's there, E's there, let's join them up. Here we've got, that's the diagonal of that rectangle. So in terms of that rectangle, this would be a right angle there. We know that BE is equal to 8 centimeters, and we've actually worked out what BC is already. We worked out that BC is 5 centimeters. The length of that diagonal there is 5 centimeters. So we just need to use Pythagoras' theorem again to find out the length of CE. I'm just going to draw a sketch of that triangle BCE. So let's draw a sketch of that triangle BCE. Okay, so there's our little right angle triangle. I'm just going to go back up here. So we have got B and then C and then E. So let's label those B and then C and then E. BC is equal to 5 centimeters. We've worked that out. And BE was equal to 8 centimeters. So there's our measurements. Now let's use Pythagoras' theorem to find the length of CE. So that's the hypotenuse, the longest side. So A squared plus B squared equals C squared. The two shorter sides, so 5 squared plus 8 squared equals C squared. In this case, I've just called that X, so X squared. 5 squared is 25 plus 8 squared is 64. And then if we add them together, we get X squared. 25 plus 64 is 89, and that's equal to X squared. And then if we square root that, we get that X is equal to the square root of 89. And you can leave your answer like that if you wanted to, or if you square root it, you get that's equal to 9.433981132. So I'm just going to write that down to 3 decimal places, 9.434 to 3 decimal places, and that's it. Okay, let's have a look at our next question, question number 8. So question number 8, we're told that AB is the diagonal of a cube. So we've got this cube and AB is the diagonal of that cube. As you can see, it goes from the back left top hand corner to the front bottom right hand corner, like so. And we're asked to work out the volume of this cube. So we want to find the volume of this cube. So this time we've been told the length of the diagonal. The length of the diagonal is 8 centimeters. Now, we're not actually told any more information. So what I'm going to do in this question is I'm going to try and work out the length of the diagonal. So I'm going to call the side length of the base x. So I'm going to say that's equal to x. Obviously it's a cube, so that'll be x and that'll be x and so on. So I'm going to say the side length's x, that unknown side length. And once we find that, we can then find the volume of the cube. But we need to find what that side length is. Okay, so what I'm going to do is I'm going to have a look at the base of this shape. I'm going to consider our little triangle on the bottom. So I'm going to join up from here to here, like I've done in the questions so far. And I'm going to say that's a right angle triangle. That's x, and then that would be x. And we could use Pythagoras' theorem to find the length of the diagonal of the base here. Then once we find the length of that diagonal, and we know the length of this height is going to be x here, then we can use Pythagoras' theorem to find out the length of the hypotenuse. Now we know that's equal to 8. Then hopefully we can use that then to work out what x is. And then once we find x, then we can find the volume of that cube. Okay, so let's go back to this triangle on the base here. So this right angle triangle. So the two shorter sides are the x, and we're here trying to find this length here. I'm going to just call that y for the moment. So here for this right angle triangle, a squared plus b squared equals c squared. A squared, that's going to be x squared, plus b squared, that's going to be x squared as well. And that's equal to c squared. I'm just going to call that y, so it's going to be y squared. X squared plus x squared would be 2x squared, and that's equal to y squared. And then if we want to find out what y is, we're going to square root. So y would be equal to the square root of 2x squared. So that means that this distance here, from here to here, would be the square root of 2x squared. I'm just going to get rid of that y and write 2x squared there. So that's the length of that diagonal. Okay, so that's great. So now if we have a look at this triangle here, where AB is the length of the diagonal, so we've got this triangle here, so AB would be the length of the hypotenuse of that triangle. So then if we consider Pythagoras' theorem for that triangle, we would have a squared plus b squared equals c squared. A and b are the two shorter sides, so we're going to let a be equal to x, that'd be x squared, plus b squared, well, that's going to be this side squared, so that'll be the square root of 2x squared, close bracket, squared, so it's that side squared, is equal to c squared, the hypotenuse squared, so that'll be 8 squared. Okay, x squared is just x squared. And then if we work out what we get if we square the square root of 2x squared, well, if you square root something and then square it, you're just going to get what's under the square root symbol, so that'll be 2x squared, because obviously if you the square root of 2x squared, and you times it by the square root of 2x squared, you're just going to get 2x squared, and that's equal to 8 squared. Okay, so this is fantastic. We've now got an equation with x's in it and numbers, so we'll be able to work this out. So x squared plus 2x squared, that's going to be 3x squared, and that's equal to 8 squared is 64. And then if we divide both sides by 3, we're going to get that x squared is equal to 64 over 3. And then x would be the square root of this. So let's work out the square root of this. So I'm going to do the square root on my calculator, the square root of 64 over 3. And I get that to be, as a decimal number, 4.618802154. So that is x. So that is the side length of this cube. So this would be equal to 4.6188 and so on. This would be 4.6188 and so on. The height would be 4.6188 and so on. So if we want to find the volume of the cube, we just need to do 4.6188 cubed, or times it by itself and by itself again. So let's write that down. So if we want to find the volume will be equal to 4.6188 and so on, multiplied by itself and multiplied by itself again. And of course you could just write it as volume equals 4.6188 and so on cubed, because that's how you'd get the volume of it. So if we just cube that, so I'm just going to press the cube button on my calculator, and that's equal to, the volume will be equal to 98.53444594 centimeters cubed. And I'm just going to round that, and I'm going to round it to 3 decimal places. That'll be 98.534 centimeters cubed to 3 decimal places, and that's it. Okay, let's look at our next question, question number 9. So question number 9, we've been given this triangular prism, and we're told the volume of this triangular prism is 151.2 centimeters cubed. We know that AC is equal to 4 centimeters and BC is equal to 5.8 centimeters, and we've been asked first of all to work out the length of BF. So we want to find the length of BF. So before we do that, what we're going to do is we're going to use the fact that the volume of the prism is 151.2 centimeters cubed. So if I wanted to find the volume of this prism, what I would do is I'd find the area of the cross section, this right angle triangle, by doing half the base times the height, and then I would times by how long the prism is, and then that would give me the volume of the prism. But in this case, we're missing two things. We're missing the length of the base of this triangle, and we're missing the length BF, how long the prism is. So let's find the length of the base to begin with. So here we've got a right angle triangle. This is the right angle, so that means that BC is the hypotenuse. This is the longest side. I'm just going to label it C. And that means that this side and this side will be A and B. So that's A and B, the two shorter sides. So if we use Pythagoras' theorem, we can find out what AB is. So let's do that. So A squared plus B squared equals C squared. A squared, that's going to be 4 squared, plus B squared, I'm just going to call that B squared, is equal to C squared. So that'll be 5.8 squared. So 4 squared, that's 16, plus B squared, what we're trying to find, our B. And then if we do 5.8 squared, that's equal to 33.64. Now we want to find out what B squared is, so let's take away 16 from both sides of the equation. So if we take away 16 from both sides of the equation, on the right hand side we'll be left with 17.64. And then if we square root that, so we do the square root of 17.64, so it's the square root of 17.64, that's equal to 4.2. So B is equal to 4.2 centimeters. So that means that B is 4.2 centimeters. So that's fantastic. So now if I wanted to find the volume of this prism, remember we would find the area for the cross section. So that's half the base times the height. So we can do that. And then we would times it by the length to find the volume. So that's great. So let's find the area for the triangle and then divide the total volume by the area of the triangle, and that'll tell us the length of the prism. So let's find the area for the triangle to begin with. So the cross-sectional area. So the cross-sectional area, and that's the area of the triangle. So we're going to do half the base times the height. So it's going to be half of the base, which is 4.2, times the height, which is 4. And when we work that out, we do a half of 4.2 multiplied by 4. That's equal to 8.4. So that's 8.4 centimeters squared. So that's the area for this cross section, 8.4 centimeters squared. Now, if we wanted to find the volume, we would take that area, that 8.4, and we would times it by this length here, and that would give us the volume. So if we take the volume, the 151.2 centimeters cubed, and we divide it by 8.4, that'll give us the length. So let's do that. 151.2 divided by 8.4 is equal to 18. So that means that that is 18 centimeters. So that's the length of BF. Okay, so that's fantastic. So we've done part A. Then if we go down, part B. Part B says work out the length of BE. So we want to find the length of BE. So if we look at this sloped rectangular face here, BCEF, this rectangular face here, we want to find the length of BE. So I'm just going to mark that on with a little line here. So B to E would be that line there. And we want to find the length of that. So that's a right angle triangle. So we could either look at triangle BCE or BFE. They're both right angle triangles. We know that BF is equal to 18 centimeters. We've just worked that out. EF would be the same as BC, so that's going to be 5.8 centimeters. And we're trying to find the length of BE. So let's actually sketch this right angle triangle to begin with. So it's a right angle triangle. We have got our BFE, so BF and E. BF is 18 centimeters and EF was equal to 5.8, so 5.8 centimeters. And we want to work out BE. So we're going to use Pythagoras' theorem. A squared plus B squared equals C squared. And I've labelled the sides A and B being the shorter sides and C being the longer side. So A squared plus B squared equals C squared. So that'll be 5.8 squared plus 18 squared equals C squared. So let's work this out. So I'm going to just type in my calculator 5.8 squared plus 18 squared, and that's equal to 357.64, and that's equal to C squared. And then if we do the square root of that, C would be the square root of 357.64, and when we do the square root of that, we get that's equal to 18.91137.224. And I'm just going to round that. I'm going to round it to 3 decimal places. That'll be 18.911, and that's it. Okay, let's have a look at our next question. We've got this cone, and we've got the diameter at the base of the cone is 6 centimeters, and the slant height of the cone is 10 centimeters, and we've been asked to work out the volume of the cone. So it's going to be 3D Pythagoras because we've got a 3D shape here, and we're going to be using Pythagoras' theorem. And what we want to do is to find the volume of the cone. The volume of a cone is equal to a third the area of the base, which would be pi r squared, because it's a circle and the area of a circle is pi r squared, times the perpendicular height. So the perpendicular height is the height going from the top of the cone down to the base. So that height, rather than the slant height, the perpendicular height is the height, the height going straight up. So we want to find the perpendicular height. So if we consider this, we want to find this height here. And to find this height here, we're going to split this up into a right angle triangle. So in terms of this right angle triangle here, that will be a right angle. We know the hypotenuse of that right angle triangle will be 10 centimeters. In terms of this part here, that would be 3 centimeters, because that would be the radius going from the center of the circle to the edge of the circle. So that would be 3 centimeters. And we're going to use Pythagoras' theorem to find the height of that triangle, that right angle triangle. And the height of that triangle will be the perpendicular height of the cone, and then we can just use the formula to find the volume of the cone. So let's do that. So Pythagoras' theorem is a squared plus b squared equals c squared. So the two shorter sides, I'm just going to call that h for the minute. A squared, that's going to be 3 squared, plus the other shorter side squared, so that's going to be h squared, equals c squared, which is 10 squared. 3 squared is 9, so that's 9, plus h squared is just h squared, equals, and 10 squared is 100. And then if we take 9 away from both sides, we get that h squared is equal to 91. And then we're going to square root both sides here, so h would be equal to the square root of 91. Now you could leave it like that if you wanted to, or you could write it as a decimal number. The square root of 91 is equal to 9.539392014. And try not to round this. If you are using the decimal number, try not to round it. Keep it on your calculator display, because if you round it, you're going to lose some accuracy whenever you're working out the volume of the cone. So I either use the square root of 91, leave it as a third, or leave it on your calculator display like I have, or if you need to type in the whole thing. Okay, so the volume of a cone is equal to a third of, if we have a look here, pi r squared, so a third times pi, times the radius of the base, which is 3, and then squared, times the perpendicular height, which is equal to 9.539, and so on, the whole number there, or root 91. And when we do that in our calculator, we do a third multiplied by pi, multiplied by 3 squared, multiplied by, now I've already got this on my answer, so I'm going to press answer there, or you can just type it in, the square root of 91, or 9.539, and so on. You get the volume will be equal to 89.9066561 centimeters cubed. And that's it. And I'm going to round my answer to one decimal place, so that'll be 89.9 centimeters cubed to one decimal place. And that's it. Okay, let's look at our next question, question number 11. Okay, so question number 11. Question number 11, we've been given a square base pyramid. So we've got this square base pyramid, A, B, C, D, E. And we're told that F is the midpoint of CD. So CD is one of the sides of the base. It's a square base pyramid. So if that's 6 centimeters, that's 6 centimeters. And that obviously means then that if the whole thing is 6 centimeters, that DF would be 3 centimeters. And that CF would be 3 centimeters as well, because F's the midpoint. We're told that AD is equal to 6 centimeters. Yep, we know that. And we're told that CE is 10 centimeters. And the question says to work out the length of BD. So we want to work out the length of BD. So that is the length of the diagonal of the base. So the base is a square, and we want to find the length of that diagonal. So that's a right angle triangle, and we've got 6 centimeters there for AD, and the AB would be 6 centimeters. So they're the two shorter sides, and the diagonal will be the longer side. So that means if we do A squared plus B squared equals C squared, we'd have 6 squared plus 6 squared, so 6 squared plus 6 squared equals, I'm just going to call that X, that's equal to X squared. So 6 squared is 36, plus 6 squared is 36, and that's equal to X squared. 36 plus 36 is 72, and that's equal to X squared. And then if you square root it, you get that X is equal to the square root of 72. So that means that X, the length of BD, is equal to the square root of 72. So I'm going to leave it as square root of 72 there. I'm just going to write it as a decimal number as well. The square root of 72 is equal to 6 root 2, or 8.48528137.4. I'm just going to round the answer here to 3 decimal places. That'll be 8.485. But even though I've rounded it and written the answer in there as 8.485, if I need to use the length of BD again in this question, I'm going to use either this or the square root of 72, because I don't want to lose any accuracy. Okay, if we go on to part B, we've been asked to work out the length of EF. So EF, so E is the top of this square base pyramid, and here we've got F. So let's actually make a little right angle triangle there. So we have got, if we go from E straight down to the middle of the base there, and then to F, that would be, and then from E to F, what we're trying to find, that would be a right angle triangle. So you can see there's a right angle triangle. I'm going to call that point there the midpoint of the base. I'm going to call that M for the minute for the midpoint. So we've got this triangle EMF, where M is the midpoint of the base, the middle of that square. E would be directly above it. It would be a right angle triangle, and we want to work out the length of EF there. Now, things that we do know here, we do know what MF is, or FM. That's equal to 3 centimeters, because if the whole width is 6 centimeters, to the middle would be, going straight across would be 3 centimeters. That's great, that's 3 centimeters. We do need to find the height of the pyramid. So to find the height of the pyramid here, to find the height of ME, the height of the pyramid, I'm going to consider the triangle EMD. I'm just going to draw over it in a minute in blue, and then I get rid of it. So going from E straight down to M, the midpoint, forward to D, and then going up that diagonal there. And considering that triangle, we can actually work out the height of the pyramid, because if we know that CE is equal to 10 centimeters, DE would be 10 centimeters as well. And this is a right angle triangle. This triangle EMD is a right angle triangle. We actually also know the length of MD, because if we know that BD is equal to this 8.48 and so on, MD would be half of that. It's half of the way across that diagonal. So going from B to D is equal to root 72, or 8.48 and so on. Going from the midpoint of that line to D would be equal to half of that. So we know the length of the hypotenuse of that right angle triangle, EMD. And actually I'm just going to sketch EMD here to begin with. So I'm actually just, let's get rid of that triangle, let's get rid of that blue writing to begin with, and let's do a little sketch here of the triangle EMD. So EMD would look like this. And then once we find out the height of that triangle is, then we know the height of the pyramid, then we can go back to the triangle EMF. So this is the triangle EMD, going from the top of the pyramid down to the middle of the base, across diagonally to D, and then up that diagonal all the way to E. Okay, now we know from M to D would be half of B to D. So I'm going to take the answer BD and I'm going to divide it by 2. So BD is equal to root 72. I'm just going to divide that by 2, and that's equal to, if I divide that by 2, it's equal to 3 root 2. So 3 root 2. Or as a decimal number, 4.242640687. So that's half of our answer to part A. Okay, so that is the length of MD. So I'm just going to write that there, 4.2426 and so on, or 3 root 2, depending on which version you want to use. Okay, now we know what ED is, because if we know EC is equal to 10 centimeters, ED would be 10 centimeters as well. And this is a right angle triangle, so we can use Pythagoras' theorem to work out what EM would be. So let's do that. So let's use Pythagoras' theorem here, and I'm going to call the two shorter sides A and B, and the longer side C. So A squared plus B squared equals C squared. A squared, well, that's going to be 3 root 2 squared, plus B squared, well, that's going to be what we're trying to find here, B squared, equals 10 squared. Okay, 3 root 2 squared is equal to 18, so that's 18 plus B squared is equal to 100, because 10 squared is 100. And then if we take that away, we get the B squared is equal to 82, and so that means that B is equal to the square root of 82, and the square root of 82 would be equal to root 82. So it means the height of the pyramid is root 82. So that's fantastic. Now we have worked out the height of the pyramid is root 82. If we have a look now at the triangle, okay, so I'm going to go over this in the highlighter. So if we go from E down to the midpoint of the base, across the F, and then up diagonally now. So this is the triangle we're looking at now, okay? And we already know from M to F is 3 centimeters, because it's half of the way across the base, which is 6 centimeters, so that'll be 3 centimeters. And we've just worked out that ME is equal to root 82 centimeters. Don't know why I wrote that so big, but the height of the pyramid is root 82. And we want to work out EF, so I'm just going to call that Y. So I'm going to sketch this triangle just down below, so that's the triangle EMF. So let's sketch that. Okay, so I've just sketched triangle EMF, just going to go and check. So E is the top, M is the bottom, and the center of the base, and F is that side there. We want to find out what EF is, so I've called that Y. MF is equal to 3 centimeters, and ME is equal to root 82 centimeters, and that's what we've got there. Okay, so we want to find out what Y is, which is the hypotenuse of the right angle triangle. So the two shorter sides are the 3 and the root 82. So A squared plus B squared equals C squared. So A squared, that's going to be 3 squared, plus B squared, that's going to be root 82 squared, is equal to C squared, which is Y squared. 3 squared is 9. Root 82 squared would be 82, and that's equal to y squared. 9 plus 82 is 91, and that's equal to y squared. So y is equal to the square root of 91. And that's it. So that's what EF would be. So this measurement here, this length here from E to F would be root 91. So the square root of 91, which is as a decimal number 9.539392014 centimeters. And that's it. Okay, let's have a look at our last question, question number 12. So question number 12, we've been given a triangular prism. So we've got this triangular prism. So we've got the cross section is a right angle triangle. And we've got the length AB is equal to 16 centimeters. The length AC is equal to 30 centimeters. We've got some extra points here, the point P, and we're told that the point P lies on CE, such that the ratio of C to P to C to E is equal to 1 to 5, and that Q lies on the line BF such that the ratio of BQ to QF is 3 to 1. And then if we go on down, we've been asked to work out the length of PQ. So we want to work out the length of PQ. So I'm just going to label that to begin with. So I'm just going to highlight what PQ is, that line there. So that's the line joining from P to Q. If you look at the right hand side of the triangular prism, that sloped rectangle, that would be a point at the top of that rectangle, and that'd be a point at the bottom of it, and it's that diagonal line joining them. Okay, so to work out the measurements here, what I'm going to do is I actually want to find out if I was to actually make a right angle triangle going from there down to there. So that line is parallel to BC, so this line here, and I want to look at that right angle triangle there. Because if we have this right angle triangle going from P down to here, I'm just going to call this point here, let's call it R. If we had the triangle PRQ, that would be a right angle triangle. And if we can work out what PR is, and we can, if we have a look at this right angle triangle, we use Pythagoras' theorem to work out what CB would be, and CB would be the same length as PR, so that's great. We can find the length of PR quite nicely. And then if we can use these ratios to work out the length from R to Q, then we can use Pythagoras' theorem to work out the length of that diagonal. So let's do that. So let's start off with the easy part. Let's find the length of PR to begin with. So if we look at this triangle ABC, let's use Pythagoras' theorem to work out the length of BC. So let's do that. So we've got our two shorter sides. So if we use our A squared plus B squared equals C squared. Our two shorter sides are our 16 and our 30, and our BC is our longest side. So we're going to have A squared is 16 squared plus B squared is 30 squared is equal to BC squared. So let's work this out. 16 squared is equal to 256 plus 30 squared is equal to 900, and that's equal to BC squared. And 250 plus 900 is equal to 1156 or 1156, that's equal to BC squared. And then if we square root that, the square root of this, BC would be equal to the square root of 1156, and that's equal to 34. So that's fantastic. BC is equal to 34 centimeters. So that means that PR would also be equal to 34 centimeters. And we'll label that on in a minute, but we've worked out the PR is 34 centimeters. Okay, now we need to actually work out the length of RQ. So this bit here, we're going to now need to consider these ratios. These ratios will help us work out this distance and this distance and this distance and this distance, and then we'll be able to work out that distance there. I'm just going to highlight these. I want to work out this distance here, and then I want to work out this distance here. If I can work out this distance, and I know that BF, the whole length is 60 centimeters, if I can take this distance and this distance away from 60, what's left will be RQ. So let's work out what CP would be and what QF would be. Okay, so let's start by considering the position of the point P. So we know that P lies on CE such that CP to CE. So CP to CE is the ratio 1 to 5. So in other words, this is 1 from C to P, and then the 5 would be from C to E, so the whole way. So if that is 1 and that's 5, that means that that's 1/5. This distance would be 1/5 of the whole distance. Now what's great is we know what the whole distance is. The whole distance is 60 centimeters. So if we just do 60 divided by 5, that's equal to 12. So that means that from C to P would be 12 centimeters, and then from P to E would be the rest, which would be 48 centimeters. And let's just check that. The ratio of CP to CE, well, CP would be 12 and CE would be 60. Well, if you cancel down 12 to 60, you get 1 to 5. So that's fantastic. So we know that's 12 centimeters. So that's great. We now just need to find out what QF is. So this time we're told that the point Q lies on the line BF such that BQ to QF is 3 to 1. So let's just highlight those again. So BQ, that's 3 parts, and QF is 1 part. So that's 3 parts and that's 1 part. So we're going to share the 60 centimeters out in the ratio of 3 to 1. So let's do that. So if we take 60 and we want to share in the ratio of 3 to 1, so we do 3 plus 1 is equal to 4. And then if we do 60 divided by 4, that's equal to 15. And then if we do 15 times 3, that's equal to 45. And 15 times 1 is equal to 15. So that means the BQ would be 45 centimeters. And the bit that we're really looking for, QF, would be 15 centimeters. And let's just check that. If this was 45 centimeters and that's 15 centimeters, if you cancel down that ratio, you get 3 to 1. So that's fantastic. So this is great. We now know that CP is 12 centimeters and the QF is 15 centimeters. Now let's take them both away from 60. So let's do 60, take away 12, take away 15 and see what we get. So 60 take away 12 take away 15 is equal to 33. So that means that RQ is 33 centimeters. So RQ is 33 centimeters, and PR, we worked that out earlier, PR is equal to 34 centimeters. So now we can use Pythagoras' theorem on this triangle PRQ to work out the length of PQ, and let's just call that Y, and we know that's going to be the longest side of that triangle. So it means that 33 and 34 are the two shorter sides, and we want to find out what Y is, that length of PQ. So let's write down Pythagoras' theorem. A squared plus B squared equals C squared. A squared, well, that's going to be 33 squared, plus B squared, that's going to be 34 squared, is equal to C squared, and I've called that Y, so Y squared. So 33 squared plus 34 squared is equal to 2,245, and that's equal to Y squared. And then if we square root that, Y would be the square root of 2,245, and that's equal to 47.3814396 centimeters. And I'm going to round it to 3 decimal places. So the 3 decimal places, PQ, would have a length of 47.381 centimeters to 3 decimal places, And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on 3D Pythagoras. If you need any extra help on using Pythagoras' theorem in 3 dimensions, go to Corbettmaths and go to the videos and worksheets page and scroll down to video number 259. Alternatively, you can scan this QR code. But in this video, I went through the video solutions to the practice questions. I really hope you found this video useful. And if you have found it useful, please like and please subscribe to my YouTube channel. Thank you. Cheers. Bye.